Hi, welcome to the statics tutorials. So for this problem, we have a rigid body, ABC. Point A is connected to a smooth frictionless pin. Point B is connected to a smooth frictionless roller. We have a 100 Newton force that acts halfway between A to B. It's at an angle of 50 degrees to the x-axis. And then we have a 150 Newton force that acts up here at C that's at a 20-degree angle to the y-axis. We want to find the resultant moment about this point B here where a roller is. And then we want to also find the resultant moment about point A from this loading. We can completely neglect the thickness of the beam in our calculations. So let's look at sum of moments about B. We have the 100 Newton force here. If we think about now the x and y components, let's first look at the y component. That would be 150 newtons sine of 50 degrees. The y component has this x separation from point B. So this would be the 4 meters minus the 2 meters would give us the 2 meters. Thinking about point B, that y component would give us a negative moment or a clockwise moment about B, so the negative sign here. When we look at the x component of the 100 newtons, it goes through point B, and so it can't contribute a moment. So there is nothing in this equation from the x component. Looking up here at this 150 Newton force at point C, we have the x component, which is 150 newtons sine of 20 degrees. We're using sine because the angle is to the y-axis. And then this x component has this y distance of 3 meters. Thinking again about point B, that x component gives us a negative moment about point B, so we've got the negative sign here. The y component at C goes right through point B, and so it can't create a moment, and so we don't have anything in this equation for that. Calculating this out, we get the two terms. Again, they're both negative. Units are going to be newtons times meters, so Newton meters. Add it together, we get the negative 306 Newton meters. And sometimes you'll also see it written this way. So 306 Newton meters with the clockwise sign on it to show that it's a negative or clockwise moment. Now looking at the moment about A, you can see that we get a different value. And let's go through and see why that is. The 100 Newton force has an x component that still goes through point A, so the x component of the 100 newtons still doesn't show up in this sum of moments about A. The y component would go here, and so it would be separated by this x distance of 2 meters, and so the magnitude winds up being the same, 100 newtons sine 50 times 2 meters, but when we're at A, you can see that that y component creates a positive moment about point A. Over here, looking at this 150 Newton force, if we think about the x component, that's our 150 newtons sine 20, it's still separated by this same 3 meters of vertical distance, and so that term winds up being the same, and the x component still winds up producing a negative moment about A. Let's take a look at the y component here at C. So that's going to be 150 newtons times cosine of 20. And then we're going to look for the x distance over here to A. And that x distance is 4 meters. So that's our 4 meters here. This y component of the 150 Newton force is going to create a negative moment about point A. So it gets that negative sign there. We add it all up, and then we get a negative 565, also in units of Newton meters, and then we could write that as 565 Newton meters with the clockwise sign. Thanks for watching.